Today we begin a brand new unit, Unit 5. Unit 5 covers a variety of polygons with a primary focus on quadrilaterals, which are four-sided polygons. A polygon is a two-dimensional figure that is made up of three or more straight lines. Today is the only day that we will not focus on quadrilaterals, but we'll learn formulas that will assist us in finding the sum of the interior and exterior angles of a polygon, in addition to finding the measure of each angle of a regular polygon. A regular polygon is a polygon in which all sides and angles are congruent. Last unit we learned about regular triangles, which are called equilateral or equiangular triangles. You recall a theorem from last unit called the exterior angle theorem of a triangle. It's right here. This theorem states that the sum of any two interior angles is equal to the exterior angle of the other angle, or the off angle. When you think about the three angles of a triangle, you are always thinking about the three interior angles. Exterior angles are formed when a side is extended beyond the vertex of one of the angles, creating a linear pair. Remember, a linear pair is supplementary, which means it adds up to 180. So today there are four basic concepts that we're going to be learning about. The first is how to find the sum of the interior angles of a polygon. Second is how to find the measure of an interior angle of a regular polygon. Third is going to be finding the sum of the exterior angles of a polygon, and then how to find the measure of an interior angle of an exterior angle of a regular polygon. Then we're also going to go in reverse and try to figure the number of sides of a figure if given the total of the degrees of the angles or one of the angles. So to find the measure of an individual angle, regardless of whether it is interior or exterior, you simply take the sum of the angles and divide it by the number of sides or angles. In a figure, the number of sides is going to correspond to the number of angles that are going to be the same. All right, so let's talk about finding the sum of the interior angles of a polygon. I want to first take a look at this chart, and for the first page of your notes, this is what you need to have written down. So if you want to take a picture of that, that's fine. So this is the top half for page 53, and that's the bottom half. So again, if you want to take a picture, go ahead, you'll have it. Okay. So to find the sum of the interior angles of a polygon, you should already know the sum of the interior angles of two polygons, triangles, and quadrilaterals. The three angles of a triangle add up to 180. Four angles of a quadrilateral add up to 360. But if you did not know that, it's okay, because essentially all you need to know for now is that triangle angles add up to 180 degrees. The reason I say you should already know that the four angles of a quadrilateral add up to 360 is because think about a square. A square has four right angles, which means they're 90 degrees each. 90 times 4 is 360. So that's where you get the 360 from. So you hopefully already know those two. Take a look at the first page of the interior angle, exterior angle sum notes. You see the pictures of four figures right here: triangle, quadrilateral, pentagon, hexagon, in order by the number of sides. So triangle's got 3 sides, quadrilateral 4, pentagon 5, hexagon 6. The sum of degrees in a polygon can be determined by figuring out the number of triangles that can be drawn within the polygon. If you look right here, there's 2 triangles drawn there, 3 there, 4 there. To create the triangles in each polygon, what you do is you start at any one of the vertices of the polygon. Okay, you start right there, and then you draw a straight line to the other vertices. But you don't draw a line to the two that it's adjacent to, because if you did, you would be essentially tracing the side. So you just draw a straight line to the other vertices. So there's one there, just starting there. So for the pentagon, you start there, draw 1, 2, hexagon, 1, 2, 3, and so on. So once that will then produce the number of triangles. So as you see, a quadrilateral has 2 triangles, pentagon has 3, hexagon has 4, and there's a pattern there. So you take the number of sides and you divide and subtract 2 from it, and that will give you the number of triangles in the figure. And then remember, there's 180 degrees in a triangle, so you take the total number of triangles in the figure and you multiply it by 180, and that gives you the total number of degrees for that polygon. So triangle right here, of course we already know is 180. So here you would take, so you got 2 triangles there, 2 times 180 is 360. 360. And then here, 3 triangles there, 3 times 180 is 540. This column here is the number of triangles, and this is always going to be 2 less than this. Here, that your paper is going to say sum of interior angles, which is going to be this large number. You notice a pattern, it goes up by 180 each time, and then I've also drawn a line here, and what this number here is the measure of each interior angle of a regular equilateral triangle, regular quadrilateral, which would be a square, regular pentagon, regular hexagon. And all these numbers will be used frequently on your homework and let's see it on your test as well. Let's talk about finding the measure of an interior angle of a regular polygon. So we're going to go down here, talk about these formulas. So we really just talked about it there. One way to you can do it is by using this formula, but I'd rather you not think about formulas. Rather you kind of think about it this way, and you just take the number of the given polygon and subtract 2 from it, and then whatever number that is, multiply it by 180. So like for example 5, subtract 2 from 5, you get 3, 3 times 180 is 540. And then so let's flip over and look at these problems here. So these are the first couple of problems. You want to go ahead and copy these down on your notes. So the first one, you're going to look for 2 things in these problems. You're going to first look if they're talking about interior angles or exterior angles. These are obviously interior angles. Second thing you're going to look for is if it's asking for the sum or if it's asking for an individual angle. So it's looking for the sum, it'll say sum. If it asks for an individual angle, it'll usually say each interior angle or each exterior angle when we get to those problems. So here's the sum, here's each angle, and remember the difference of the 2 is when you use the same formula or find it the same way, you just divide it by the number of sides to get each angle. So here it's a 15-gon. When we get to 10, just on the other page it goes up to a 10-sided figure being a decagon. When you get past 10, you get to 11, 12, 13, you refer to those figures as 11-gon, 12-gon, 13-gon. So this is a 15-gon, so that means it's a 15-sided polygon. So you take 15 minus 2, which is going to be 13. 13 times 180 is 2340. So the total number, the sum of the interior angles of a 15-gon is 2340 degrees. For number 2 here, it's asking about an 18-gon, the measure of a regular 18-gon, each interior angle. So we do 18 minus 2, which is 16 times 180, is 2880. Divide that by the number of sides, which is 18. That gives us 160 degrees. So that's for interior angles. Now let's go ahead and talk about exterior angles. So to find the sum of the exterior angles of a polygon, you don't need to find anything. You just need to commit to memory one number. That's 360. A trick a lot of students use is if you think about traveling all the way around a world, think of the world as being kind of a sphere, and if you go all the way around it one time until you're facing the way you were, when you get all the way, that's a 360. So it doesn't matter what the size or how many sides the figure has. The sum of the exterior angles is always going to add up to 360. These are here a linear pair, so these will add up to 180. So we do 180 minus 79 to get 101, 180 minus 61 to get 119, 180 minus 40 to get 140. Those 3 add up to 360. It's going to be the same thing here. If we did figure all those out, add up to 360, same thing there, and same thing there. And then to get the exterior, the individual angle, you take 360 and divide it by the number of sides or angles. So as you see for number 3, again, we're looking to see if it says exterior or interior. It says exterior, and then it says measure of each. That's each one, so we do 360 divided by hexagon. So hexagon's 6. So you're going to need to commit to memory these right here. You're going to need to know that a hexagon is 6 sides. I'd like for you to try to memorize these as well. Septagon 7, octagon 8, nonagon 9, decagon 10. So again, 360 divided by 6 is 60. And then here's is slightly different. There will be some questions that ask how many sides. And so you set it up in reverse. So we're looking for, we've got 12 degrees over here. So 360 divided by the number of sides. If you have a problem like this, you can switch these two numbers right here and put the 12 in the denominator and equaling n. So 360 divided by 12 is going to be 30. So it's going to have 30 sides. Right, so the next video will actually have assistance on the, to help you with your homework. We'll go over the practice problems, the one done in class.